Hello folks, welcome back to another exciting episode of Mr. V Teaches Math. Today we're going to be looking at equivalent fractions. So our goal today, because I like to share them with you guys, is to identify and to write equivalent fractions. But before we do that, what I thought we would do today is just have a bit of a review. We'll look at some pictures that have some things shaded in and some things not, and we'll just try to identify the fractions. So the first picture over to the left, we have a triangle. It's got 3 sections total. One of them is colored in, and so what we can say is that it's represented as 1/3. Okay. Here we have a square divided up into 4 boxes, and 2 of those boxes are colored in red, and so we can say that it's represented by 2/4. Over here we have another square that's divided up into 1, 2, 3, 4, 5, 6, 7, 8 different sections, and 4 of those sections are colored in. So we say that that is 4 out of 8. Okay, here we have a slightly smaller square, and it's got 1, 2, 3, 4, 5, 6, 7, 8, 9 boxes, and it's got 1, 2, 3, 4, 5 boxes. So it's 5 out of 9 boxes are colored in. And lastly, we have a nice little triangle that's got 1, 2, 3, 4 sections total, and 1 of those is colored in. So that's a bit of a recap as to how to express fractions that are done pictorially, to express them actually as fractions with our numerator and our denominator, as we've been talking about. So if we flip over the page, let's do some equivalent fractions, and let's do it pictorially. Okay, let's talk about how to find equivalent fractions pictorially. Now, the first activity that we did to just identify some fractions was not just because. What I want us to do is to look at this picture and say, all right, so there are 1, 2, 3, 4, 5, 6, 7, 8. There are 16 sections on this fraction. 4 of them happen to be colored in. Okay, so that's my fraction. This is what we're working with, is 4 out of 16. Now, to find an equivalent fraction to 4 out of 16, all I'm going to do is I'm going to draw in a couple extra lines. So now, instead of there only being 16 sections, there are now 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. There are now 32 sections, and 1, 2, 3, 4, 5, 6, 7, 8. There are now 8 sections that are colored in. Aside from drawing in the lines, we haven't done anything else to this diagram. We haven't colored in any more squares. Just that we now have, where we once had 4, we now have 8 squares. And so what we can say is that 4 over 16 is equivalent to 8 over 32. And in a second, when we talk about numerically, I'll show you numerically how that can work. Okay? Now, let's do another one here. A nice little circle cut out and colored in. Again, this is pretty straightforward. This is 1/3. Okay, nothing too shocking. Now, if I add in extra lines, now also notice that as I add in extra lines, in each of the segments I add the same number of lines. Okay, I've now added in an extra line in each segment, so I now have a total of 6 segments, and I have 2 of them colored in. Okay, same way as if I were to just even divide it even more. And just keep adding in lines. And again, I'm adding the same number to each section. So I now have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I have 12 sections, and I have 4 of them colored in. So I can say that these 3 fractions, 1/3, 2/6, and 4 over 12, are all equivalent. Okay. Now, the first 2 examples I've shown you are examples of fractions getting larger. We're showing larger equivalencies. What I'm going to show you now is another example. I'll just move this away just for a few minutes. Now, look at this. So this is still a pictorial representation. This is it's a little bit hard to see on the video, but this is actually divided up into 4 sections. Okay, so I have 4 sections, and 2 of them are colored in. Now, if I'm going to take out a whole line, which I've done, and I've gotten rid of a whole line, I can say that there are now two sections and one of them is colored in. Okay, so this is for a half and this is 2/4. Okay, the diagram, like the amount of coloring is the same. It still represents the same thing, but now we've gotten smaller. But we can say that 2/4 is equivalent to 1/2 because they represent sort of the same looking fraction. Same way as if I were to take my original drawing, this which was 4/16, which we made 8/32. If I were to redraw that, so do I have enough room? I have enough room over here. Where I'll redraw this example. 1, 2, 3. And again, what I'm going to do is I'm going to not draw as many lines, but it's going to represent the same drawing that we had before. Okay, so notice I've only got 8 sections, and I'm going to color in the same amount, which is right here and then right here. Okay, so I've got 8 sections, and I've only got 2 of them filled in. Now if I go back to my original example, you'll notice same type of drawing, fewer lines, and we see fractions getting smaller. Okay, so that's another example of equivalent fractions that get smaller. Now, to show you how that works numerically, let's try this. So here I have several different examples. Okay, I have 1/4, I have 3/5, 9/12, and 3/12. Okay, and what I'm going to do is I'm going to start writing out equivalent fractions, but I'm going to show you how I get there. So what I'm going to do is I'm going to say that 1/4 is going to become equal to 1/4, and I'm going to multiply both of these numbers times 2. Okay, so it's 1/4 times 2, and each side 1 times 2 is 2, and 4 times 2 is 8. So I can say that 1/4 is equivalent to 2/8. I can say that 2/8, if I multiply that by 2, is equivalent to 4/16. Now if I want to get from 1/4 to 4/16, what I would have to do, 1/4 is equal to, I'm going to multiply each of these numbers by 4. Okay, so that shows you that 1/4 is equivalent to 4/16 as well. With 3/5, showing equivalency, if I want to just, let's see, 3 times 3, and then 5 times 3. Now notice that they're always I'm multiplying with the same number top and bottom. If I multiply the numerator by 4, I have to multiply the denominator by 4, pardon me, because that's going to show me an equivalent fraction. Okay, so 3 times 3 is 9, 5 times 3 is 15. I can say that 3/5 is equivalent to 9/15. Okay, I can do something again. I can say 3/3, so let's say it's times 10. So I can say that 3/3 is equivalent to 30/50. Okay. Now I know, because I've shown you here a couple of times, how to make fractions larger and show equivalency with larger fractions. But let's use an example to make something smaller. So if I take 9 and 12 and I divide them both by 3, 9 divided by 3 is 3, and 12 divided by 3 is 4. So I can say that 9/12 is equivalent to 3/4. Likewise, with 3/12, I can divide that by 3, and I can divide 12 by 3 again to get 1/4. So I can say that 3/12 is equivalent to 1/4. Okay. The last thing that I'm going to show you, I think, before I sign off for the night is just a couple of these questions. If I have 1/2 and I'm timesing it by some number, and I want to get to 2/4, think about for a second what number you would put in there, and it does happen to be 2. So just these numbers here are called scale factors, not to get too technical, but they're called scale factors. It's a number that you use to multiply it by the numerator and denominator to get an equivalent fraction. And so that's it for today, and You'll be getting some practice in just a few minutes, or sorry, rather when you get to class. Okay?